Welcome to The Explainer. Today we're diving into one of the most creative and frankly kind of mind-bending ideas in all of artificial intelligence. We're talking about generative adversarial networks, or as you probably know them, GANs.
All right, let's just jump right in with a single pretty wild question. What if a computer could just create a face? I mean, a face of a person who is never, ever existed. Sounds like something out of a sci-fi movie, right? Well, the answer to that question is really at the core of what makes this tech so incredible.
And the answer is yes. A computer absolutely can do that. And the progress? It's been nothing short of astonishing. I mean, look at this. In just 4 years, we went from these blurry, grayscale smudges to faces that are so photorealistic you literally couldn't tell them apart from a real photo. And these people, they're complete fabrications of an algorithm. This incredible leap is all thanks to generative adversarial networks.
Okay, so how on earth do they pull this off? To really get it, we need to back up just a little and understand the fundamental job they were built for. It's a whole field called generative modeling, and the name kind of gives it away, right? It's all about teaching a machine not just to recognize stuff, but to actually create it, completely from scratch. So, in machine learning, there are a couple of main ways a model can learn. You've got supervised learning, which is kind of like studying for a test with flashcards. You see a picture, and the answer key on the back tells you, yep, that's a cat. Easy enough. But GANs, they play in a different sandbox. They use unsupervised learning. This is more like giving a student a giant, massive pile of cat photos, no labels, no answer key, and just saying, hey, you figure it out. You tell me what makes a cat a cat. And even in this world of learning from patterns, there are two totally different goals. On one hand, you have a discriminative model. Its job is to, well, discriminate, to tell things apart. Think of your spam filter, right? Is this email spam or is it not? But a generative model, it has a much bigger, more ambitious goal. It wants to learn the patterns so deeply that it can dream up brand new, totally convincing examples of its own. And that's where GANs live. They're all about that second goal, pure creation.
So here's the really crucial point, the thing you have to get. A good generative model doesn't just copy-paste or remix what it's already seen. No, it learns the essence of the data. You could almost call it the statistical soul of a data set. It figures out the unwritten rules of what makes a face look like a face so that it can then generate a completely new, totally original face that still follows all those rules perfectly.
Okay, so how in the world do GANs actually do this? The real genius here isn't that there's one single super smart AI model doing all the work. Nope. The secret sauce is that the entire system is designed as this brilliant, competitive game between two players.
And the best way to think about it is this. It's a game of cat and mouse. You've got a counterfeiter versus the police. One neural network, we call it the generator, is our master counterfeiter. Its only job in life is to create fake money that looks totally real. And its opponent, the discriminator, is the detective. Its only job is to spot the fakes.
And this kicks off this relentless cycle, this feedback loop. The counterfeiter makes a fake, the detective spots it and says, nope, that's a fake. The counterfeiter takes that feedback and uses it to create a better fake. Well, now the detective has to get even smarter to spot the new, improved forgery. Round and round they go, each one forcing the other to get better and better. It's this perfect adversarial loop of improvement.
Okay, so let's drop the analogy for a second and talk about the real players here. Let's meet the actual neural networks that are locked in this game, the generator and the discriminator.
And as you can see, their jobs are polar opposites. The generator, our counterfeiter, it starts with nothing but a string of random noise. You can think of it like a block of digital marble, and its job is to try and sculpt that marble into a realistic image. Now the discriminator, our detective, it gets shown a mix of real images from the training data and the generator's latest forgeries. And its goal is super simple. Call them out. Correctly label every single one as either real or fake.
So you might be wondering, how does this game end? When does the generator win? Well, the system reaches this beautiful equilibrium point. It happens when the generator's fakes get so good, so convincing, that the discriminator is basically just guessing. It gets it right only about half the time. At that point, the game is over. We've achieved our goal. We now have what we wanted from the start, a master forger, a generator that can pump out incredibly plausible examples whenever we ask.
All right, so we've gone through all this elaborate game of cat and mouse to train a perfect digital counterfeiter. Now what? What's the point? What can we actually do with it? Well, my friends, this is where the theory turns into straight-up magic.
I mean, the applications they're all over the place. For example, you can take a blurry, low-res photo and have a GAN realistically dream up all the missing details, making it super sharp and clear. That's called super resolution. Or, get this, you could train a GAN on all of Van Gogh's paintings, and then it could generate completely new, original paintings in his iconic style. It's wild. They can even help out other AIs by creating extra training data when you just don't have enough real-world examples.
Now, this is all amazing, for sure, but there's a catch with a basic GAN. It just gives you a random, high-quality image. But what if you don't want just any random face? What if you wanted to specify, say, a man with glasses and a beard? What if you wanted to actually steer the ship and guide the creative process?
Well, that's exactly the idea behind a super important upgrade called conditional GANs, or CGANs for short. The trick is simple but brilliant. You give both the generator and the discriminator an extra piece of information, a label, a condition, and that condition acts like a steering wheel, letting you direct the output exactly where you want it to go.
And with this control, you can do some truly incredible things. You can give the GAN a line of text, like a photorealistic image of an astronaut riding a horse, and poof, it generates it from scratch. You can feed it an old black and white photo and say, make this color, and it will intelligently colorize the whole thing. You can even do stuff like take a photo of a summer landscape and tell it to make it winter, and it will realistically transform the scene, adding snow and changing the lighting. It's a game changer.
So what's the big takeaway here? The main thing to remember is that GANs aren't just some clever party trick. They represent a really fundamental breakthrough. It's AI learning to understand our world so deeply that it can actually start creating new parts of it. Whether it's solving real-world problems like data scarcity or just opening up completely new frontiers for digital creativity, GANs are truly changing what's possible.
But you know, as we stand back and admire this incredible creative power, the very success of GANs forces us to ask a really profound and maybe even urgent question. When the AI forgers become perfect, when the fakes are literally indistinguishable from the real thing, how do we know what's real anymore? That line between what's real and what's generated starts to get very, very blurry. And that's a challenge that, honestly, we're all going to have to figure out as this technology keeps racing forward.